In this episode, we will talk about solar eclipses, when the sun disappears in the middle of the day and the world simply forgets how to behave. Birds fall silent, winds stop moving, temperatures drop like a stone, and even your brain reacts as if something ancient has awakened inside it. This moment lasts only a few minutes, but it carries mysteries we still cannot explain. Tonight, let's step into the only natural event that stops the entire Earth at once. These aren't just shadows crossing the sun. They're some of the rarest and most beautiful alignments nature can create. You might think you already know what a solar eclipse is, the moon moving in front of the sun. But the truth is far more magical than most people ever realize. You see, the sun and the moon look exactly the same size in our sky. But that's only true for today. Millions of years ago, the moon looked huge. We live in the only era where the moon can perfectly cover the sun, like a key fitting perfectly into a lock. And one day, that key won't fit anymore. The moon is slowly drifting away from Earth, about 4 centimeters every year. It doesn't sound like much, but it's enough that in about 600 million years, no creature will ever see a total solar eclipse again. The universe is giving us, in our tiny moment of history, a front row seat to one of its rarest tricks. Long ago, eclipses lasted far longer than today. Because the moon was closer, its shadow covered Earth for 10, 11, even 12 minutes at a time. Imagine standing in sudden darkness, the air cooling, the stars appearing in the middle of the day, for as long as a song. Today's longest eclipses barely reach 7 minutes. The universe is slowly changing the show. And the geometry that makes a solar eclipse possible is so unbelievably perfect that it almost feels intentional. The sun is 400 times wider than the moon, but also 400 times farther away. The numbers match so precisely that a difference of just a few meters in distance can turn a total eclipse into an annular one, a ring of fire instead of full darkness. It's one of the rarest size coincidences known in the entire universe, and it doesn't happen anywhere else we've seen. Not on Mars, not on Jupiter, not on any exoplanet so far. Earth is the only world, the only one we know, where the moon can hide the sun perfectly. Eclipses depend on everything lining up just right. The moon's tilt, its distance, Earth's rotation, even the shape of the moon's mountains. If any of these things were even slightly different, the sun would never disappear behind the moon's shadow. When an eclipse does happen, the shadow that falls on Earth is incredibly small, sometimes only 90 miles wide, a tiny dark fingerprint on a huge spinning world. And that little shadow races across Earth at thousands of miles per hour, faster than a speeding jet, faster than sound itself. As the last bit of sunlight shines through the deep valleys on the moon's edge, the light breaks into tiny bright spots, called Bailey's beads. Most people have never heard of them, but during those few seconds, you're looking straight at the rugged shape of the moon drawn by sunlight. And then suddenly, the world changes. The sun disappears. And for the first and only time, you see something that is always there, but always invisible. The sun's outer atmosphere, the corona, a glowing, white, ghostly halo stretching millions of kilometers into space.
The corona is hotter than the sun's surface by 1,000,000 degrees, a mystery scientists still don't fully understand. But in those quiet minutes of totality, you get to see it with your own eyes. And that is just the beginning of what eclipses hide. What you're seeing isn't just darkness, it's geometry on a cosmic scale, a perfect alignment that almost never happens. And one of the strangest things about a solar eclipse is how much the sun's corona reveals when the moon finally blocks its blinding light. The corona is usually invisible because the sun is too bright. But during totality, those few precious minutes when the moon hides the sun, you can see streamers and magnetic arcs stretching millions of kilometers into space. They twist and glow like white fire, shaped by the sun's magnetic field, dancing in slow motion. Sometimes, if the sun is especially active, you can even see violent loops of plasma called solar prominences, huge arcs of glowing gas erupting from the surface, things so large they could wrap around Earth dozens of times. But strangely, you can only see them clearly when the moon steps in and dims the world for a moment. And that's just one type of eclipse reveal. There are eclipses that are even more rare, events most people will never hear about in their entire life. Take hybrid eclipses, for example. They're so rare that only about 3 to 5% of eclipses become hybrids. In some places, the eclipse is total. The moon perfectly covers the sun. But in other locations on Earth at the same moment, the eclipse is annular. The moon is too far away, and people see a glowing ring of fire instead of darkness. A single eclipse, two completely different shows happening at the same time. Most people don't know that eclipses can even switch between these forms mid-path, changing from annular to total and back again, as the moon's shadow plays with Earth's curve. And then there are eclipses that no human ever sees, eclipses that happen entirely over oceans, or eclipses that fall over Antarctica, visible only to penguins and science stations.
Some eclipses flash into existence for mere moments. One recorded totality lasted 0.08 seconds. So fast, you would blink and miss a miracle. Others stretch themselves out, hugging the maximum limit of the universe's geometry. The longest possible total eclipse is around 7.5 minutes, and some ancient ones even lasted longer because the moon used to be much closer. Even the shape of the eclipse path is something most people don't realize. On maps, it looks like a simple curved line, but on Earth, that line moves at impossible speeds, up to 5,000 miles per hour. You're watching a shadow tear across continents faster than a supersonic jet. And if conditions are extremely rare, you can witness something even stranger. A solar eclipse with optical effects scientists call horizontal distortions, where the sun looks like an oval or a melting shape as it climbs the horizon. Atmospheric bending stretches it, turning the eclipse into something surreal and dreamlike. And sometimes, a specific angle between Earth, Moon, and Sun creates an eclipse where the corona forms bright double streamers, like two huge wings of white fire opening on each side of the darkened moon. Moments that look almost too perfect to be real, and yet they last only a heartbeat. Then the world returns to light. As we drift through these quiet facts, it becomes clear that solar eclipses aren't just astronomical events, they're cosmic accidents, rare alignments, tiny miracles that happen only because the
the sun, the moon, and Earth decided to dance in just the right way, at just the right moment in time. And somehow, we're alive in the era where we can witness them. You already know there are total eclipses and partial ones, and the glowing ring of fire annular eclipses, but somewhere between them lives a kind of eclipse most people will never witness or even hear about: the hybrid eclipse. A hybrid eclipse is like the universe changing its mind mid-performance. In some places on Earth, the moon looks just big enough to hide the sun completely, a total eclipse. But elsewhere along the same path, the moon seems just a little too small, creating a fiery ring instead. The same eclipse, two different endings, just because Earth is curved and distances shift ever so slightly as the moon's shadow touches our world. That's how delicate eclipses are, how sensitive this dance is. A tiny change in distance, a small curve in the Earth, a little stretch in sunlight, and suddenly the show becomes something new. Some hybrid eclipses only switch types for a few heartbeats. Others shift slowly and gracefully as the shadow moves over oceans and continents. They are among the rarest eclipses the universe creates. Events that happen only every few decades, and even then, only in tiny strips of Earth that most people never visit. And then there are eclipse paths that humans never see at all. Some sweep across nothing but ocean, a dark shadow racing over waves, seen only by whales, birds, and lonely research ships. Others pass over Antarctica or the Arctic, where the only witnesses are penguins, seals, and scientists wrapped in layers of frost. Whole eclipses happen without a single human eye to catch them. And sometimes the universe creates eclipses so brief that you could blink and miss the entire event. One lasted less than a tenth of a second, a moment so fast that even if you were staring right at it, your mind might not register the darkness at all. But on the opposite end of possibility are eclipses that stretch toward the edge of what the universe allows. The longest totality we can ever get is about 7.5 minutes, a number controlled by orbital speeds, distances, and Earth's curvature. Some eclipses in ancient times came close to this limit, and as the moon was once closer to Earth, their totalities lasted even longer. Imagine standing under darkness for almost 10 minutes in the middle of the day, the world silent, the air cold, the sun replaced by a hole in the sky.
You might think an eclipse path is straight, a clean slice across a map, but that's only because we flatten Earth onto paper. The real path curves naturally because the world itself curves. The shadow bends, twists slightly, and wraps around the planet in ways that maps can't show. And depending on where you stand on Earth, you'll see the sun's shape change too. Near the horizon, the atmosphere stretches sunlight, making the eclipsed sun look squashed, oval, or melted, as if the universe is painting with soft, warm fingers. Sometimes, if the moon and sun align in exactly the right way, you'll see streamers in the corona form special patterns called double-winged shapes, like glowing feathers opening slowly behind the moon. Each one is unique, formed by the sun's magnetic field, revealed only for the few minutes when the world grows quiet. Stranger still, the eclipse path itself can create multiple dark tracks, shadow paths that split or twist or overlap because of Earth's rotation, the moon's wobble, or atmospheric bending. Tiny differences in angle,
distance, and timing can shape the eclipse's shadow into patterns that exist for only minutes and then are gone forever. As we drift through these rare truths tonight, it becomes clear that solar eclipses are not just astronomical events, they are delicate cosmic accidents, miracles made from precision and chance, shaped by distances, shadows, and time. A solar eclipse is not just a visual event, it is something the entire world seems to feel. The moment sunlight begins to thin, animals sense it long before we do. Birds go quiet, as if night has crept in early. Bees stop flying and return to their hives. Even insects like ants and butterflies pause their movement, confused by the sudden shift in brightness, as if the world holds its breath, waiting. You'd think only humans watch an eclipse, but nature watches too, with instinct, with silence, with stillness. And as sunlight fades further, something extraordinary happens in the trees. Leaves, sensing the sudden drop in temperature, can cool so quickly that moisture inside them contracts. In that tiny moment, if you listen closely, some trees give off faint snapping sounds. Not loud, not sharp, but soft little pops, created by the rapid change in heat. We often think eclipses affect only the sky, but the truth is that every plant, every branch, every leaf reacts to the sudden loss of warmth. It's the world adjusting itself, trying to understand a moment that is both night and day at the same time. Down on the ground, stranger things unfold. Light passing through small gaps, through tree leaves, through fingers, even through a straw, creates thousands of tiny crescent-shaped images of the partially covered sun. Most people walk by without noticing these beautiful hidden signs all around them. Every little beam of light becomes a miniature projector, painting crescent suns onto sidewalks, walls, clothing, tiny reminders that the sky is doing something remarkable above. These crescents are like silent whispers from the eclipse, scattered in places only the calmest eyes would ever think to look. Then there are the mysterious shadow bands, one of the rarest and least understood parts of a solar eclipse. Just before totality, faint waves of darkness begin rippling across the ground, like invisible water flowing over sand. They move quickly, thin, shifting bands of light and shadow racing across walls and fields. Scientists still don't completely understand how these bands form, but they believe they're caused by tiny irregularities in Earth's atmosphere bending the last slivers of sunlight, as if the air itself becomes a living lens, trembling with excitement as darkness approaches. People who witness shadow bands often describe them as eerie, otherworldly, or even unsettling, a reminder that the universe is filled with mysteries we can see, but not fully explain. And when the moon finally covers the sun completely, temperatures drop fast, sometimes 10 degrees or more, and the sudden cooling creates something scientists call eclipse winds. The air that had been warmed by sunlight no longer has heat pushing it upward, so winds flatten and shift direction. A stillness falls first, like the pause between breaths, and then new breezes form, flowing outward from the path of the shadow. These winds are gentle, almost ghost-like, and disappear the moment the sun returns. It feels like the earth itself shivers under the surprise of sudden night. Animals react during this time in ways that can feel strangely emotional. Farm animals wander back to their barns. Birds that were mid-song drop into silence. Nocturnal creatures begin their nighttime routines, only to stop again when daylight returns minutes later. Even humans respond. People cry. People gasp. People forget to speak. There is something deep and ancient inside the human mind that recognizes this temporary darkness, something instinctive that senses the world has broken its pattern even just for a moment. And as while all of this happens on the ground, the sky performs its own silent show. When sunlight disappears, the horizon doesn't go black. Instead, it glows with a 360-degree sunset, a ring of orange and red circling the world. It's a sunset in every direction at once, created because sunlight is still hitting the atmosphere, far from the shadow, but not where you stand. It is one of the most surreal sights in nature, like living inside the center of a giant glowing bowl. And above that glowing ring, stars and planets appear suddenly, bright, sharp, unblurred by the usual daylight haze. Venus often shines first, like a jewel dropped into the sky, then Mercury, then constellations you only see at night. For those few minutes, day and night merge gently, holding hands in the sky. It's not darkness, it's a strange in-between state, soft and unreal, as if the world is dreaming while awake. And just as your mind begins to adjust to the calm of totality, the universe gives one final surprise. As the moon begins to move again, sunlight bursts through its mountains and valleys in a single golden flash, the diamond ring effect, signaling that day is returning. That bright moment marks the end of nature's confusion, the end of the strange cold, and the end of the world's stillness. Light rushes back, animals resume their routines, winds return to normal, and nature exhales, as if waking from the shortest dream.
You might think an eclipse path is straight, a clean slice across a map, but that's only because we flatten Earth onto paper. The real path curves naturally because the world itself curves. The shadow bends, twists slightly, and wraps around the planet in ways that maps can't show. And depending on where you stand on Earth, you'll see the sun's shape change too. Near the horizon, the atmosphere stretches sunlight, making the eclipsed sun look squashed, oval, or melted, as if the universe is painting with soft, warm fingers. Sometimes, if the moon and sun align in exactly the right way, you'll see streamers in the corona form special patterns called double-winged shapes, like glowing feathers opening slowly behind the moon. Each one is unique, formed by the sun's magnetic field, revealed only for the few minutes when the world grows quiet. Stranger still, the eclipse path itself can create multiple dark tracks, shadow paths that split or twist or overlap because of Earth's rotation, the moon's wobble, or atmospheric bending. Tiny differences in angle, distance, and timing can shape the eclipse's shadow into patterns that exist for only minutes and then are gone forever. As we drift through these rare truths tonight, it becomes clear that solar eclipses are not just astronomical events, they are delicate cosmic accidents, miracles made from precision and chance, shaped by distances, shadows, and time. A solar eclipse is not just a visual event, it is something the entire world seems to feel. The moment sunlight begins to thin, animals sense it long before we do. Birds go quiet, as if night has crept in early. Bees stop flying and return to their hives. Even insects like ants and butterflies pause their movement, confused by the sudden shift in brightness, as if the world holds its breath, waiting. You'd think only humans watch an eclipse, but nature watches too, with instinct, with silence, with stillness. And as sunlight fades further, something extraordinary happens in the trees. Leaves, sensing the sudden drop in temperature, can cool so quickly that moisture inside them contracts. In that tiny moment, if you listen closely, some trees give off faint snapping sounds. Not loud, not sharp, but soft little pops, created by the rapid change in heat. We often think eclipses affect only the sky, but the truth is that every plant, every branch, every leaf reacts to the sudden loss of warmth. It's the world adjusting itself, trying to understand a moment that is both night and day at the same time. Down on the ground, stranger things unfold. Light passing through small gaps, through tree leaves, through fingers, even through a straw, creates thousands of tiny crescent-shaped images of the partially covered sun. Most people walk by without noticing these beautiful hidden signs all around them. Every little beam of light becomes a miniature projector,
painting crescent suns onto sidewalks, walls, clothing, tiny reminders that the sky is doing something remarkable above. These crescents are like silent whispers from the eclipse, scattered in places only the calmest eyes would ever think to look. Then there are the mysterious shadow bands, one of the rarest and least understood parts of a solar eclipse. Just before totality, faint waves of darkness begin rippling across the ground, like invisible water flowing over sand. They move quickly, thin, shifting bands of light and shadow racing across walls and fields. Scientists still don't completely understand how these bands form, but they believe they're caused by tiny irregularities in Earth's atmosphere bending the last slivers of sunlight, as if the air itself becomes a living lens, trembling with excitement as darkness approaches. People who witness shadow bands often describe them as eerie, otherworldly, or even unsettling, a reminder that the universe is filled with mysteries we can see, but not fully explain. And when the moon finally covers the sun completely, temperatures drop fast, sometimes 10 degrees or more, and the sudden cooling creates something scientists call eclipse winds. The air that had been warmed by sunlight no longer has heat pushing it upward, so winds flatten and shift direction. A stillness falls first, like the pause between breaths, and then new breezes form, flowing outward from the path of the shadow. These winds are gentle, almost ghost-like, and disappear the moment the sun returns. It feels like the earth itself shivers under the surprise of sudden night. Animals react during this time in ways that can feel strangely emotional. Farm animals wander back to their barns. Birds that were mid-song drop into silence. Nocturnal creatures begin their nighttime routines, only to stop again when daylight returns minutes later. Even humans respond. People cry. People gasp. People forget to speak. There is something deep and ancient inside the human mind that recognizes this temporary darkness, something instinctive that senses the world has broken its pattern even just for a moment. And as while all of this happens on the ground, the sky performs its own silent show. When sunlight disappears, the horizon doesn't go black. Instead, it glows with a 360-degree sunset, a ring of orange and red circling the world. It's a sunset in every direction at once, created because sunlight is still hitting the atmosphere, far from the shadow, but not where you stand. It is one of the most surreal sights in nature, like living inside the center of a giant glowing bowl. And above that glowing ring, stars and planets appear suddenly, bright, sharp, unblurred by the usual daylight haze. Venus often shines first, like a jewel dropped into the sky, then Mercury, then constellations you only see at night. For those few minutes, day and night merge gently, holding hands in the sky. It's not darkness, it's a strange in-between state, soft and unreal, as if the world is dreaming while awake. And just as your mind begins to adjust to the calm of totality, the universe gives one final surprise. As the moon begins to move again, sunlight bursts through its mountains and valleys in a single golden flash, the diamond ring effect, signaling the day is returning. That bright moment marks the end of nature's confusion, the end of the strange cold, and the end of the world's stillness. Light rushes back, animals resume their routines, winds return to normal, and nature exhales, as if waking from the shortest dream.
Solar eclipses don't just change the sky, they change the world below it. You might think an eclipse only affects the sky, but the truth is that Earth's atmosphere responds in ways that almost feel alive. The air cools suddenly, dropping not just in temperature, but in movement. Warm air that used to rise freely no longer has the sun's energy pushing it upward, and the atmosphere settles into a stillness that's impossible to create any other way. It's like the sky itself takes a slow, deep breath and pauses, a hush falling over the world that you can feel in your bones. During that pause, the brightness of the sun changes in a way your eyes rarely get to notice. Even before totality, sunlight becomes thinner, more directional, sharper. Things begin to look clearer and more defined, as though someone has turned up the contrast on the world. Shadows stretch longer and grow edges so crisp they almost look painted. This happens because the sun, once a wide glowing disk, shrinks into a thin crescent of light, a concentrated beam instead of a broad daylight glow. The world becomes a place of outlines and sharp shapes, a kind of eerie clarity that feels both familiar and strange. And then there are the shadow bands, those rare, rippling waves of light that appear on walls, roads, and grass just seconds before totality. They move fast, sliding like invisible fingers across the ground, and disappear just as quickly. Most people never see them, either because they don't know to look or they're lost in the excitement of what's happening above. Scientists think these bands come from warm and cool air mingling as the last sliver of sunlight bends through Earth's atmosphere. It's like the air becomes a lens, fracturing and shimmering as tiny waves flow through it. Watching shadow bands feels like witnessing a secret, a brief, trembling preview of the darkness about to arrive. When totality finally settles in, and darkness wraps around the world like a velvet curtain, Earth undergoes a transformation that goes far beyond dimming light. Temperatures can drop by 10 or even 15 degrees in minutes, a change so sudden that the atmosphere winces. Wind patterns reverse, quiet breezes turn inward, and the ground radiates a chill that feels unreal. This rapid cooling creates eclipse winds, soft currents of air that form only during the brief minutes without sunlight. They whisper across the land and vanish just as quickly, like a gentle sigh from the earth itself. And as the world cools, humans, even if they don't admit it, feel something deep and instinctive stirring inside them. Our ancestors lived in a world without science, so sudden daytime darkness meant danger, mystery, or divine signs. Even though we understand eclipses now, our bodies still feel the old instinct. During totality, some people cry without knowing why. Others gasp, or freeze, or laugh, or simply stand in stunned silence as if their minds are trying to catch up with something ancient and powerful. Researchers studying human emotion can actually measure changes in the brain. Eclipses trigger spikes in awe, in wonder, in feelings of connection and humility. The universe shrinks down to one rare moment, and for just a few minutes, everyone becomes still. But far above this emotional world, the sun reveals things it hides every other moment of the year. During totality, the sun's corona appears, this soft, ghostly halo stretching millions of kilometers into space. It swirls gently, pulled and shaped by magnetic fields we cannot see. And sometimes, hidden in that white glow, you might catch a glimpse of solar prominences, gigantic arcs of red and pink plasma looping above the sun's surface. These loops are so large they make Earth look like a grain of dust. Yet during an eclipse, they appear delicate, like glowing petals floating in slow motion. And somewhere far beyond the sun, planets appear out of the blue-black sky. Venus glows like a lantern. Mercury, tiny and fast, suddenly becomes visible in broad daylight. Stars emerge around the corona as if night has sneaked into the afternoon. For those few minutes, day and night blend together in a peaceful, impossible harmony, and you stand at the center of it all, feeling small and infinite at the same time. A solar eclipse is not just shadow. It's not just light.
It's not just science. It's a moment where the entire Earth, air, animals, light, temperature, wind, and even human emotion changes together, quietly, beautifully, as if obeying a single command from the sky. And in the stillness that follows, when the sun returns like a slow golden sunrise, the world feels just a little different, as though you've witnessed something you weren't entirely meant to see. Do you know that the moon used to be far closer to us? So close that ancient eclipses were longer, darker, and more dramatic than anything humans will ever witness today. When the moon was young, it took up more of the sky. Its shadows stretched wider across Earth, and totality could last more than 10 minutes. But with every passing year, the moon drifts away by a few centimeters, a slow, gentle migration that will one day end total eclipses forever. There will come a time, millions of years from now, when the moon appears too small to fully cover the sun, and the world will never again experience the deep, soul-stilling darkness of totality. We live in an incredibly lucky moment of cosmic history where these breathtaking alignments are still possible. Eclipses have done more for science than most people ever realize. Long before satellites, telescopes, and spacecraft, the corona, that glowing white halo around the eclipsed sun, was a complete mystery. Scientists desperately wanted to understand it, but it was invisible during normal daylight.
Only during a total eclipse, the corona appear like a ghostly crown of light stretching millions of kilometers outward and far hotter than the sun's surface, filled with magnetic loops and plasma streams that bend, twist, and shimmer. Astronomers first discovered that the corona behaves like a giant flowing magnetic storm, a place hotter than any flame, yet so delicate it disappears the moment sunlight returns. Every eclipse became a chance, a rare, precious chance to study the sun's hidden heart. But eclipses didn't just teach us about the sun. They also helped scientists measure things we can't normally see. During an eclipse, the sky darkens enough to reveal stars close to the sun's edge, stars that are usually lost in the bright daytime glare. In 1919, scientists photographed these stars and discovered that their positions shifted slightly, not because the stars moved, but because the sun's gravity bent the starlight itself. This was the first real proof that gravity can bend space and light, the first evidence confirming Einstein's theory of general relativity. And all of that knowledge, all of that world-changing science, came from a few minutes of darkness during a total solar eclipse. Even our understanding of the universe's elements has been shaped by eclipses. In 1868, scientists studying the sun's spectrum during an eclipse discovered a strange yellow light that didn't match any element known on Earth. They realized the sun was made of something new, an element later named helium, after Helios, the Greek god of the sun. Imagine that, an element first found not in rocks or oceans or Earth's air, but in the sun itself during an eclipse. Cultures throughout history have also felt the weight of eclipses in deep and meaningful ways. Ancient Chinese astronomers, Babylonians, Mayans, Arabs, and Greeks all kept careful eclipse records for thousands of years. These events were seen as omens, messages, warnings, or gifts from the heavens. Some kings planned battles around eclipses. Some civilizations paused all activity, believing the universe was giving them a sign. And others simply watched in awe, writing stories, myths, and poems about the sun disappearing in the middle of the day. And if you've ever seen people watching a total solar eclipse today, you'll notice something interesting. Human reactions haven't changed much. During totality, adults freeze, kids gasp, strangers hug each other, people cry without understanding why. It's like something ancient inside us remembers a time when sudden darkness meant mystery, danger, or divine power. Modern science explains the eclipse, but our hearts still feel the old instinct. It's a reminder that no matter how advanced we become, there are still moments that can quiet the human mind and open the human heart. And perhaps one of the most beautiful things about an eclipse is the way it brings people together. Millions travel across countries just to stand under the same shadow for a few minutes. Airlines run special flights so people can chase the shadow from the sky. Some travelers follow eclipses around the world, collecting memories of darkness like rare treasures. Totality doesn't last long, just a few minutes, but those minutes are powerful enough to create lifelong stories. Eclipses don't just show us the sun and moon. They show us ourselves, our curiosity, our emotions, our sense of wonder, and our shared desire to witness something bigger than our everyday lives. Most people never stop to think about how differently an eclipse changes the world compared to a normal sunset. During a sunset, the sky fades from one direction, west to east, as Earth slowly turns away from the sun. But during a solar eclipse, the light dims from all directions at once. It's like standing inside a giant dimmer switch that lowers the brightness of the whole planet evenly, smoothly, softly. Your brain isn't used to that. Nothing else in nature darkens the world in that perfect, symmetrical way. And because the light thins rather than warms, the sky transforms into a deep, velvety blue that feels calmer than night, as though the atmosphere itself is trying to whisper, something rare is happening. Up above, the sun's shape becomes distorted by Earth's atmosphere, flattened slightly, stretched slightly, as if melting at the edges. When the solar crescent thins to just a sliver, even the tiniest waves of air can change the sun's shape, turning it into shimmering curves or trembling lines of golden light. You might not notice it unless you look carefully, but the sun is never perfectly round during an eclipse. Heat waves rising from the ground bend light differently. Clouds refract it differently. Dust shifts the glow. For a moment, the sun becomes something fluid, a dancing shape painted by the atmosphere around you. As the light fades even more, stars begin to appear, not hours later when the sun finally sets, but now, in the middle of the day. Venus is usually the first to shine, bold and bright on the opposite side of the sky. Mercury follows, small but sharp, finally visible without the sun's brightness drowning it out. And if the sky is especially clear, you may see constellations that belong to the invisible night, peeking through like shy storytellers, taking advantage of a rare, quiet moment in daylight. For a few minutes, you are living between worlds, not quite day, not quite night, a strange twilight created by the moon's shadow. Down below, the temperature continues its rapid drop. In some places, it has fallen more than 10 degrees in just minutes, a shift so sudden that birds confuse it for evening. They stop singing, they settle in trees. Some even return to their nests early, not realizing the sky is playing a trick on them. Bats have been seen emerging early during totality, thinking night has come. Nocturnal animals stir. Diurnal animals fall silent. Nature itself pauses. A moment of quiet so complete you can almost feel your heartbeat echoing in it. Humans feel it too.
People often describe a strange tightness in their chest, or a wave of emotion rising unexpectedly. Some say they feel goosebumps when the shadow arrives. Others say they feel small, or humbled, or overwhelmed by the sudden stillness. Psychologists studying this effect have discovered that eclipses trigger a powerful emotional response in the human brain, a mixture of awe, surprise, and deep connectedness. For those minutes of totality, you're not just observing the universe, you're inside it, wrapped in its shadow, experiencing the cosmic machinery directly. And while the sky darkens, scientists use this rare window to study secrets normally hidden in daylight. During a total solar eclipse, the sun's magnetic loops, its fiery plasma arches, become visible around the edges of the moon. Under special conditions, these loops can form elegant curved structures called coronal fans or coronal streamers, glowing like white feathers in slow motion. Each shape is unique and depends on the sun's magnetic activity at that exact moment. No two corona patterns are ever alike, which means every eclipse reveals a different face of the sun, a face we only glimpse for minutes at a time.
If the eclipse happens near the horizon, everything becomes even more surreal. The sun may look stretched sideways, like a glowing coin sliced with gentle pressure. Mountains or buildings can distort the shape further, casting long, dreamlike shadows that blend with the moon's darkness. This rare horizontal eclipse looks almost like a gateway in the sky, a bright, golden crack opening in the dark. And sometimes, if the moon's orbit aligns in a very specific way, the eclipse reveals double coronal wings, symmetric streams of light on each side of the moon, making the sun appear like a glowing celestial bird unfolding its wings in silence. A shape so beautiful, so alien, that many people who witness it never forget it for the rest of their lives. All of these strange, delicate moments, the navy blue sky, the trembling crescent sun, the sudden coolness, the silent animals, the glowing corona, the planets peeking in today, come together only because of one thing: the perfect, fragile geometry between the sun, the moon, and Earth. Solar eclipses like the ones we see on Earth don't exist anywhere else we know in the entire universe. Other planets have moons, other moons cast shadows, but none are the perfect match that ours is. Mars has two tiny moons, Phobos and Deimos, but they're too small, too jagged, too uneven. Their shadows sweep across the Martian surface like quick scratches of darkness, never covering the sun fully, never revealing a breathtaking corona. Only Earth, with its moon placed at exactly the right distance, gets total solar eclipses, the kind where the sun disappears and a glowing halo explodes into view around a dark circle. It's a cosmic coincidence so rare that if the moon were just a little farther away, or a little smaller, or a little heavier, we would never experience totality at all. This perfect balance, this delicate symmetry between sizes and distances won't last forever. Every year the moon drifts a tiny bit farther from Earth, almost like it's slowly floating away, 1 quiet centimeter at a time. Millions of years from now, eclipses will look completely different. Instead of totality, future beings, whoever they are, will only see annular eclipses, with the sun shining like a fiery ring around a too small moon. Total solar eclipses will become extinct, gone forever, a beautiful phenomenon lost to time. And that means the beautiful shows we witness today are not only rare, they are temporary. We live in the only era where the sun and moon appear exactly the same size in the sky. That alone is a miracle. If you could step back far enough, far beyond Earth, far into space, you'd see something else remarkable. Earth casts its own shadow into the solar system during an eclipse. From space, the moon's dark umbra looks like a small, sharp black spot racing across the surface of our world. It's stunning and silent and powerful, a dark bullet gliding over oceans and mountains at thousands of miles per hour. Satellites have captured this tiny moving darkness, showing us a perspective no human eye could ever see from the ground. Earth wearing a patch of moving night in the middle of the day. Solar eclipses can even affect the technology we rely on. GPS signals which bounce between satellites and Earth can become slightly distorted during totality. The sudden cooling of the upper atmosphere changes how radio waves travel, creating small errors in navigation systems. Most people never notice. Your phone simply corrects itself, but for a moment, even our machines feel the eclipse, as if the sky is reminding us that nature still holds the final say. Deep in the animal world, creatures react to these sudden changes in ways that scientists only recently started understanding. Birds tracked with GPS tags have been seen dropping altitude sharply during totality, descending as though night has come early. Farm animals grow restless or move towards shelter. Bees stop buzzing altogether. It's a ripple of confusion and instinct that sweeps across ecosystems in a matter of minutes. Even solar panels, those quiet collectors of sunlight, feel the eclipse too. They can lose up to 95% of their power instantly, like someone unplugged the sun. Entire energy grids prepare months in advance to handle this sudden, temporary drop. In that way, a solar eclipse becomes a gentle reminder of how deeply everything on Earth depends on one distant star and its steady light. But one of the most incredible things eclipses reveal is the sun's magnetic personality. Most of the time, we can't see it. The sun looks perfect, a glowing circle in the sky. But during an eclipse, the sun's corona expands in the darkness, showing delicate loops and streams shaped by invisible magnetic forces. Some of these arcs stretch tens of Earths in length, curling like flames frozen in motion. If the sun is especially active, you might see the corona stretch into long, thin rays that fan outward like wings. Every eclipse shows a different pattern, a different shape, a different personality of the sun that we normally can't see because daylight hides it from us. And just as the corona reveals the sun's magnetic field, Earth's atmosphere responds in unexpected ways as well. The sudden drop in sunlight cools the upper layers quickly, creating tiny atmospheric ripples that travel outward like waves in a pond. These ripples can be detected by sensitive instruments and sometimes show up as shifting patterns in the sky. Faint wave-like distortions that are nearly invisible to the naked eye. It's like the air itself is trembling as it adjusts to the temporary loss of heat. Then there's something even stranger. Earth's rotation changes ever so slightly during eclipses. It's a small shift, far too small to feel, but measurable. Tiny temperature changes, atmospheric movements, and pressure shifts all combine to subtly alter the planet's rotation speed for just a moment. It's as though Earth pauses just a fraction of a heartbeat as the shadow passes over. All of these things, the changes in air, the shifts in gravity, the animals reacting, the sun revealing its hidden face, the moon racing across the sky, come together during those few minutes of totality in a way that feels almost sacred. It's a moment when science, nature, emotion, and mystery merge into one quiet symphony played only in the rarest possible circumstances. Some eclipses in history have been so short, so delicate, that totality lasted less than the blink of an eye. The shortest ever recorded totality, a mere 0.08 seconds, vanished almost as soon as it appeared. Imagine standing under the sky, feeling the world dim, and then, in the tiniest flicker of darkness, the sun returns as if it had never left at all. Moments like that remind us that eclipses are not just spectacles, they are fragile alignments,
vulnerable to the smallest shifts in distance and angle. On the other side of possibility lies the opposite extreme. The rare eclipses predicted centuries in advance that will stretch totality toward the maximum that the laws of physics will allow. In the far future, one eclipse is predicted to create one of the longest totalities in human history. Over 7 minutes of deep midday night. Scientists have mapped it out exactly using orbital mathematics so precise that they can tell where the shadow will fall hundreds of years from now. It's strange to think that the sky itself carries a schedule written in the language of gravity and motion, waiting patiently for the right moment to unfold. But what's even more remarkable is that solar eclipses have never just been about astronomy. Throughout history, they have shaped beliefs, decisions, and destinies. Thousands of years ago, Babylonian scholars recorded eclipse cycles with astonishing accuracy, long before they understood the science behind them. Mayans built entire calendars around eclipse rhythms. Chinese astronomers were held responsible for predicting eclipses, and some even faced severe consequences if they failed to warn the emperor. To many ancient civilizations, an unpredicted eclipse was not a scientific event, it was a cosmic warning, a sign that the heavens had been disturbed. Entire wars paused. Kings delayed decisions, armies retreated. Something as simple as a shadow could change the fate of nations. Even in more recent centuries, eclipses held unexpected power.
In 585 BC, a famous eclipse suddenly darkened the battlefield between the Medes and the Lydians. Both sides, terrified by the sky's strange behavior, dropped their weapons and agreed to peace. One shadow, lasting only a few minutes, ended a war that could have raged for years. Stories like these show how deeply eclipses touch the human spirit, how even now, with all our knowledge, a total eclipse can pull feelings out of us that we didn't know were waiting. And perhaps that's why so many people today travel thousands of miles to stand under the shadow of totality. They call themselves eclipse chasers, and they follow the moon's shadow around the globe, witnessing darkness again and again, collecting moments of wonder like rare treasures. Some people have seen 10, 20, even more eclipses in their lifetime. Each one unique, each one unforgettable. Airlines plan special flights that race the moon's shadow through the sky, letting passengers see totality for far longer than anyone on the ground. It's a kind of devotion, a love for the sky that has grown into its own quiet tradition. But eclipses aren't only beautiful. They're also powerful enough to gently reshape the world around them. During totality, Earth's temperature drops so quickly that atmospheric waves ripple away from the shadow like soft echoes. Scientists can detect these ripples as they move across the upper atmosphere, mapping the invisible shiver that an eclipse sends rolling across the planet. And those temperature shifts affect everything from wind patterns to the behavior of migrating birds to the movements of insects that live their entire lives by the timing of sunlight. But perhaps the most mysterious part of all is what happens inside us. Humans weren't designed for daytime darkness. There is something ancient in our brain that reacts the moment the sun disappears. During totality, the human mind lights up with a powerful mix of emotion and awe. Scientists measure changes in heart rate, breathing, and even brainwave activity as people experience a solar eclipse.
It's not just surprise. It's a deep, instinctive shift, like touching a part of nature that we rarely get to feel. Some people cry without knowing why. Some stand perfectly still. Some whisper. Some gasp. It's the emotional fingerprint of witnessing the universe move. And as totality continues its silent journey across Earth, another rare effect sometimes appears. A quiet echo of light created by dust in the solar system reflecting the fading glow of the sun. These tiny reflections, called eclipse light echoes, can make parts of the sky shimmer faintly, as though the shadows themselves are glowing from within. It's subtle, delicate, and gone in minutes. Another whisper of the cosmos that only appears when everything aligns just right. When the shadow finally passes, when the sun peeks out from behind the moon and the diamond ring bursts into brilliance, another transformation happens. Earth warms quickly, winds return, animals resume their routine, and the world breathes again. But something inside you stays quiet for a little longer, as though part of your mind is still standing in the shadow, still listening to the soft conversation between the sun and the moon. Solar eclipses remind us that even in a universe so large, so old, and so complex, there are moments where everything, every orbit, every tilt, every piece of timing lines up in absolute perfection, just long enough to leave us breathless. If you're still awake, and if your eyes haven't completely given in to sleep yet, I'd love to invite you to be a deeper part of this little universe we're building here. You can gently tap the like button if this story helped you relax tonight, and if you want more calm science journeys like this, you can softly press subscribe so you never miss the next bedtime adventure. And if you want to make this moment a little more special, tell me in the comments where you're listening from and what time it is in your world right now. I read every single message, and it always feels incredible to see how far this peaceful community reaches across countries, time zones, and continents. You can also share this video with a friend who might need a calm night, a quiet mind, or a gentle way to fall asleep. Sometimes a single video is enough to turn a restless evening into a peaceful one. And if you want to keep drifting without interruption, you're welcome to explore the Bedtime Science Talk playlist. It's filled with more quiet cosmic journeys, more soothing stories, and more gentle explanations designed to help you sleep deeply while still feeding that little spark of curiosity inside you. But if your eyelids are heavy now, if your breathing is slow, if you can feel that warm pull of sleep settling in, you don't have to do anything at all. Just let go. Let the world fade. Let your thoughts float. Let yourself sink gently into the softness of rest. Thank you for spending this time with me tonight. Thank you for being part of this peaceful corner of the universe. And whenever you need calm, whenever you want to wander through the stars again, I'll be right here waiting. Good night, dreamer. Sleep peacefully.